Howdy, it's tubalcain again, back with episode 3 of the Atlas Craftsman Lathe Milling Attachment series. Be sure and watch episode 1 and 2 or this will not make sense to you. But I progressed this far and noticed that there's a big similarity between the original Atlas and my model made with the compound from the Atlas lathe. And I'm working now, and I've been working about the last hour. I made a mock-up of the vise portion of the attachment, and this is how I'm going to make it. This of course is just a hardwood, but it's going to look like this. It'll have a hole, 1.5-inch hole bored in the back, and then this piece, the plug with the dovetail on it, is going to be a separate piece mounted in there, and I probably will pin it with perhaps a 5/16 pin going all the way through. This will be made of steel, of course. That's aluminum now on my mock-up, and this naturally will be steel. Notice that there's 2 vise jaws here that came with the Atlas, and I'd like to make the size such that these would work in here. There's 2 different jaws there. Or work can be held directly in this vise. I happen to have these nice hardened screws in stock, so I don't have to worry about that. So let's go over to the bench now and talk about how I'm going to make these 2 parts. This is a pretty complicated piece, or maybe not so complicated, time consuming. There's just a lot of material to remove and to machine in that piece, as there is in this. Back at the bench, the original Atlas is 2.5 wide approximately and about 7/8 deep. So I'm going to model it after that, as I just said. And this is the stock that I'm going to use. Just happen to have this here in the shop, and it's the only piece I had. So I cut this hardwood the same size here so I could do some thinking. And like I told you, I often do models rather than drawings because that's the way I like to work. Don't take that as the gospel. You perhaps need to make drawings. A lot of people make drawings with dimensions, but a lot of it here is just winging it. As you know, that's the way I do a lot of the projects. All right, so this happens to be the same size. It needs to be machined on 3 sides. This is saw cut, this is saw cut, and this is saw cut. It's just cold roll steel. I hope I don't have too much trouble with warpage. I do have a big piece of cast iron, but that would require even more machining. But looking on the back side of this now, it's got that 1.5-inch hole, and on the other attachment, this is the way it would fit up, but mine is going to be fitting up in this manner, as I just showed you. That'll go in, be pinned as I just said, and this is what it's going to hold it on to the other part over in the lathe. So what I'm going to do here is start to lay this out. I actually probably should machine these pieces off so it's squared up, and I believe I will do that. I'm going to do that off camera because that's just pretty much routine work, or I might show you one shot or so of that, but I want to square up these sides. They're not so terribly unsquare as they are just rough sawn rather than smooth. So let me do that first. Over at the Bridgeport mill, I've already milled these 2 sides that were rough sawn. Now I'm going to mill the top. Now this is really way off. I just have to remove a lot of material to clean that up. But notice that I laid this out already and drilled a 1/4-inch hole. So I really just found the center in both directions because that is where I want this large 1.5-inch hole. Actually, 1.5-inch hole is neither large nor small. It's 1.5 inches. But while I have it in the milling machine and this surface trued up, I will bore that hole. Then I am assured of absolute perpendicularity. So that is the center, and then I can, I don't have to lay it out again. That's why I did that. I will drill several holes and then set the boring head up and bore that 1.5 inches. So in it goes like that on parallels. Tighten it up, and I'm using this 1.5 inch, I believe it is, maybe it's 1 3/4 carbide tipped mill. That works real nice. This may be totally unnecessary, but it's just a suggestion. Since this is rough cut and I am on parallel, I know darn well that one corner here is going to be much higher than the others, and I would just as soon start milling on the high corner rather than milling on the low corner and then really ending up with a heavy cut. You can do that with your cutter too, but using a surface gauge, I have already done this and located that this is the high corner and this is the low one, so I'm about touching here, and when I come over to this corner, I can even fit the ruler under there, you see. So I'll come over here with the cutter and start cutting here, and then it'll kind of taper off, and that's the way I do it. It's up to you. And this is real soft steel, I was glad to find out, because it's just a piece of scrap that I had around here. I don't know where it came from, but sometimes you run into a piece that's just too hard to machine and you do not want to mess with it, throw it away. Now wear your safety glasses and practice all of the rules that we use in a machine shop, because the chips really fly with this kind of cutter, and I often use this homemade chip guard as well as safety glasses. Because these things hurt so bad if you get them on the lip or up your nose. But after taking a preliminary cut, you can see that I took some off of this corner and it kind of works its way across here. So this was the high corner as indicated by the surface gauge. Now I'm ready to get serious here, and I'm not working to a dimension. I want to keep the piece as large as possible, just enough to clean it up. So here I go. Holy mackerel, that's smoky. Now some people ask me what my RPM is on a cutter this size with steel. I'm set at 700 RPM. This is a lighting test. This is a test. How do you like it? The old dark way or with my new LED light? Is that too bright and glary? Put that in the comments if anybody feels like it, but I installed an LED. Alright, off the subject there, but I have put a 1/4 inch dowel pin into the chuck and lined it up, and now I set my digital readout for 0 so I can always return to that. Now the game plan is I'm going to drill a 1/4 inch hole all the way through, even though it's going to be a blind hole all the way through, then 3/8 or whatever this is all the way through. These are stubby bits. I like stubby bits because I don't have to drop the table so much, but somebody chewed me out for calling these stubbies rather than screw machine drills. If you order these, they're going to be called screw machine, but I like to call them stubby. Remember Captain Stubby and the Buccaneers? So I won't show that. I'll drill these 2 holes, and that's just routine. Then I'll get back and I'll tell you what I'm going to do next. Now I want to explain something. This hole goes all the way through, but I want to bore a blind hole, 1.5 inches, as I mentioned before. I don't want to start boring in a hole like that. I'd have to use a tiny boring bar, so I want to enlarge that hole, but it's going to be blind from here on. So what I like to do is use an end mill. That's a 3/4 carbide end mill, and the biggest that I have that will fit in a 3/4 collet is a 7/8. I've got some bigger ones, but they won't fit in that collet. So that'll be the biggest one that I do. This is 7/8. I'm going to show you this one, but what I do is I'll bring this down until I touch off, lock the quill, and then I'm going to feed the knee up, watching the dial on the crank there. I wrote it down here, 680 thousandths. We'll see how that works. Remember, you can't go in there with an end mill without drilling first because of the lips there, the way they meet, and this is a 4-fluter. 100, 2, 3, 4, 5, 6, 'That's 680. So I'm just using an end mill as a drill bit. That's what I'm doing. It's that simple. And that'll give me a flat bottom hole. Alright, that hole is 7/8, and that's just an awful lot to still bore out. That's why I was just wanting to drill it larger. Now I don't want to use a regular drill because that won't give me a flat bottom hole. So anyway, I broke my own advice, and I have been preaching, and I do mean preaching, for years, throw away your dull cutters. But I found at the bottom of the drawer a 1-inch cutter with a 3/4 shank, but I had marked it dull at some other point, but I thought, well, that'll still get to the bottom of this. No, it wouldn't. It work hardened, it smoked, and there, now you can hear that hit the garbage can. Don't keep that dull stuff around. It will do nothing but aggravate. You can tell I'm aggravated. Alright, I cut off a piece of 1.5" stock, and it is right at 1.500, but that will be my plug gauge. And I've already set up the Criterion boring head with a boring bar, and the depth. I got the depth stop set and all that. And you know what, I'm not going to show a whole lot of this, maybe just the final pass or two, because you saw so much of this boring operation in earlier sequences. I'm progressing nicely. It's about 30 minutes later, and I've taken a reading here, and I'm at 482 thousandths, so I got about 18 thousandths to go. I'll take that in 2 or 3 passes off camera, but I kind of work up constantly taking a measurement just with the scale, and then when I get close, that's when I get serious with the precision instruments. So you just take your time on this, because you know, you go to a few thousandths over and the part is ruined. Alright, I got a good fit with my telescoping gauge, and then it's fitting the actual part. I wish I had a nice set of those plug gauges like Adam has in the larger sizes. And I'm just having to use the cold roll seal, but that's accurate enough really for what I'm doing, I guess. So now I can finally take the work out, and I think I've had enough fun for today, so I'm going up and watch Jeopardy and see how many answers I get wrong. See you tomorrow. Howdy and welcome back. It's actually 4 days later. I've been gone and I had company and I haven't been in the shop, so I actually had to go up and look at the last footage that I shot to see where I was. So I found out that I had just bored the hole and put some bluing on here, and I did some layout, which I'll talk about in just a minute here. But remember that one of the next things that I'm going to do after I finish this piece is to make this piece, but it will be made out of steel. This is aluminum, but it's my piece for test fitting. And let's go on over to tap it in there so it's flush. Oh, that's a tight fit. It's okay, because notice I provided a hole so I could drive that out. Never drive something into a blind hole unless you got don't paint yourself into a corner. I'm back at the Atlas lathe just to show you how this fits up. I do have one peg in here just snugged up so I can turn it, but it's going to swivel like that, and of course it's going to look like this. Now back to the bench, I'll show you where I'm going to cut to form this space here and how I'm going to do that. You may have noticed that I purchased a new dead blow hammer, and this came from Horror Freight, and it's only $5, which is amazing. And don't make fun of it until the jury is back, because remember, this is a Blue Point, and we talked about that, what a piece of junk that was, and that was probably a $40 hammer. So just not taking any chances. I went the cheap route, so we'll see how that holds up. Alright, that was off topic, but what I need to do now, and I've laid this out, is I'm going to mill this entire block out like that. This is the top where the 2 screws will go. This is about 3/4. this way and 2 1/4 almost this way. And here's the question. Should I saw that out? Well, I tell you what, I'd be here till doomsday with that bandsaw trying to saw that out. So instead, I'm going to reduce the entire area into chips, which is no small job, but I will use a hogging mill. And then when I get close to the lines, I'll switch to a finishing mill. But that's how I'm going to do it, because it's just such a nightmare to saw that much out when you got material this thick and you got a fairly light duty bandsaw with a dull blade. So let's go on over to the Bridgeport and mill that out. And I won't show it all because it'll be way too laborious, because there's going to be a 1/2 bushel of chips. This is a 3/4 inch hogging mill from Niagara, and I'm running at 1100 RPM. That may be too much. It's 100,000 steep. I'll slow it down. We'll see what it looks like here. Alright, that's the last cut with the hogging mill, and now I'm going to switch to a finishing mill, take just a few thousandths off down to the layout line. No measuring needed, layout line is close enough. And here's the very last pass, just a few thousandths off with a regular end mill and oil on it, and I'm climb milling. That's it, ready to take out. A real quick update here. Remember several months ago when I made these 3D printed gears for the Atlas lathe, and people were concerned that the oil would deteriorate them. Well, these gears, I cut it in half there, have been setting in Quaker State oil. Oh, I killed a bug in there. Since February 10th, and they're still in good shape with no effect of the oil at all. Back to the business at hand here now. So this looks good the way I got it milled out. I'm happy. And I just laid out these 2 holes on the top, and they're 1 5/8 inch on the center for the holes here. So I'm gonna drill and tap those on the mill. Just don't want to take the chance of anything crazy on a drill press. So it's not totally necessary, but that's my preference. Okay, back over on the Bridgeport mill. I've already located the work, and that could be done with an edge finder and the digital readout in all different kinds of ways, but I'm just going by layout lines. I used a wiggler, got a center drill, then it'll be a pilot drill, that's about 3/16, a tap drill size 5/16, and finish off with a tapered 3/8/16 tap. I could power tap it, but I got the handle out, so I think I'll do it that way. Dull center drill, I'm going to take it out and throw it away and grab another one. I won't show that. Well, this is what it looks like up to this point. I put the 2 screws in there and it's looking pretty good. Now on the original here, the Atlas product, they included 2 jaws, one with V's in it, the other just a plain piece. Now I don't know if I'll need one of these or not, but I can just use cold rolled steel. But rather than make one of these, I believe that later on I will make a V groove down into the lower part of the jaw, which might tend to weaken it a little bit. You know, I don't want this to be able to bend. This isn't all too thick, so that as I tighten it, it, you know, does this. But that's the plan. I won't be able to do this. These would work, but I don't really want to borrow them from the other. Alright, that's about enough for today. I will see you in the next episode. Be sure and watch that. This is tubalcain for right now. Bye.